Tonight, welcome to the presentation about the thoracic organs. Now I'm going to guide you through two of the most essential systems that keep us every second in the air and the nose. These organs work in perfect combination to deliver oxygen to our tissues, remove carbon dioxide, and maintain the circulation that sustains all the physiological processes. Well, begin with the heart. Uh, its structure, chamber valves, major reasons, and how it's produced and conducts electrical impulses that allow rhythm contraction. Then we move to the lungs, exploring their valves, bronchi, pulmonary arteries, and veins. And finally, the alveoli. By the end of the presentation, you will have a clear understanding of how these two organs function individually and as I element of cardiopulmonary unit. So let's begin with the heart. The heart is a muscular organ located in the mediastinum, slightly left of the midline, protected by the sternal ribs and the pericardium. Anatomically, it consists of four chambers: the right ventricle, the right atrium, left atrium, and left ventricle. Um, each chamber has a specific function, ensuring that blood flows in one direction and that oxygen poor and oxygen rich blood never mixed. The right side of the receives the oxygen and blood from the systemic circulation through the superior and inferior vena cava. This blood enters the right atrium, passes through the tricuspid valve, and reaches the right ventricle. When the right ventricle contracts, it pumps the blood through the pulmonary valve and into the pulmonary article, send it into the lungs to oxygenation. The left side of the heart works with oxygenated blood. After the lungs oxygenate the blood, it returns to the heart through the pulmonary veins, entering the left atrium. From there, it flows through the mitral valve into the into the left ventricle, which is the strongest chamber. When it contracts, it sends blood into the aorta and through the entire body. The heart also contains four main valves: tricuspid, pulmonary, mitral, aortic, and aortic. These valves prevent backflow and ensure unidirectional movement of blood. Valve function is essential because even a small failure can reduce cardiac efficiency and lead to the conditions such as no sé cuánto or stenosis. Another key component is the heart electrical conduction system. The synaptic node located into the right atrium acts as the natural pacemaker. It generates electrical impulses that spread through the atria, causing contractions. Then the impulse reaches to the atrioventricular node that through the bone of the his and continues into the Purkinje fibers, stimulating the ventricles to contract the corneal manner. This this rhythm allows the heart to pump around 5 liters of blood per minute at rest, not during exercise. The coronary arteries, which branch off the aorta, supply oxygen and nutrients to the heart muscles itself. Without the blood supply, the myocardium will not able to sustain continuous rhythm activity. Altogether, the heart It's beauty physical. The hair is a beautifully synchronized bond that never rests, beating more than 200 times per day to maintain circulations. Now moves to the lungs. The lungs are paired organs located in the thoracic cavity on either side of the heart. They are responsible for the gas exchange, the essential process of bringing oxygen into the body and removing carbon dioxide produced by cellular metabolism. Each lung is divided in two lobes. The right lung and has three lobes. Superior, middle, and inferior lung. Lobe. The left lung has two lobes, superior and inferior, because their hair occupies space of the side, forming the cardiac notch or the notch of the heart. The lungs are covered by a thin membrane called the pleura, which has two layers. The visceral pleura, attachment to the lung surface, and the parietal pleura, lining the thoracic cavity. The pleura space between them contains a small amount of fluid that reduces friction during breathing. Air enters the respiratory system through the trachea, which splits into right and left main bronchi. And these bronchi branch repeatedly into smaller bronchioles, forming a tree-like structure that distributes air throughout the lungs. At the end of the bronchioles are clusters of a tiny air sacs called alveoli. The pulmonary artery carries desioxygenated blood from the right ventricle to the lungs. This is unique because arteries usually carry oxygen-rich blood, but the pulmonary circuit is the exception. After blood becomes oxygenated in the alveoli, it returns to the heart through the pulmonary veins, which are the only veins in the body that carry oxygenated blood. The diaphragm and intercostal muscles play a crucial role in ventilation. When the diaphragm contracts, it moves downward and increases the thoracic volume, allowing air to the flow into the lungs. When it relaxes, the lung recoil and air is pushed. This cycle occurs about 12 to 20 times per minute at rest. Overall, the lungs are remarkably efficient. They contain around 3,000 million alveoli, recreating a gas exchange surface area equivalent to the size of tennis court. The alveoli are the functional unity of the respiratory system. These tiny balloon-like structures are where oxygen and carbon dioxide are exchanged between the air and the blood. Each alveolus is surrounded by an extensive network of capillaries originated from the pulmonary artery. The walls of the alveoli are extremely thin, only one cell thick, allowing gases to diffuse easily. Oxygen moves from the alveolar air into the blood, while carbon dioxide moves from the blood into alveolus to be exhaled. Surfactant, a substance produced by type 2 of pneumocystis, prevents the alveoli from collapsing and reduces surface tension, ensuring a smooth and efficient breathing. This microscopic exchange is what ultimately keeps every cell in our body alive. Thank you for your attention. Understanding the heart and the lungs is essential in medicine because these organs are central of maintaining the life. And and The coordination allows oxygen delivery, waste removal, and the regulation of every physiologic process that our bodies depends. I hope this presentation help clarify how these structures function, how beautiful interconnected the cardiopulmonary system truly is. Hace año porque se me salió eso. Pero bueno, este,